In this lab, I'm going to look at the multi-exit discriminator, or MED attribute, and how it can influence the return traffic. I've created a situation where R1 and R2 both use network statements in BGP process to advertise VLANs 10120 and 10140. As a result of that, the Autonomous System 100, in which we have peers, Internet 1 and Internet 2 here, are receiving both prefixes from both gateways, R1 and R2. Let's see how they pick the best path towards those destinations at the moment, and then we will use MED attribute to modify that behavior. So currently, if I go to and ask my Internet 1, show IP BGP, regular expression, caret marks the beginning, the left-hand side autonomous system, which is the neighboring autonomous system 500, with a space. So we're learning from our direct neighbor 500, 10120 and 10140. So the gateway here is 10110.1, which is the eBGP connection, and we also receive the same prefix from our partner Internet 2. This is the address of Internet 2 internally in AS100. So that's an IBGP versus eBGP here in the gateway here, and the best path is over eBGP. The same thing if I do, so let me just copy that real quick. If I do the same query on Internet 2, I'm receiving similar information, and it picks the best path is the router 2, which is the eBGP connection versus IBGP connection, and it actually makes perfect sense if we go to our cheat sheet here for a moment. So let's see how they actually see that. Show IP BGP maybe 10120, more detailed output as an example, so we see all of it, and we see that prefer the, let's pick one, 10120. Why do we prefer on Internet 1 the next hop eBGP, which is 10.1.10.1 versus IBGP? Because the weight is the same. So the weight is the same. Local preference is the same. We know that it doesn't show here, but it is local preference showing in this detailed output, and it's 100 and hundreds. So this one is also identical. So equal, all things equal, we go here. This is not the prefix originated by our routers, so we go to 4. The AS path length, it's just one hop. So 500 is the hop here, and 500 is here from both gateways. The code, the origin code, those codes here are identical, so both gateways advertise IGP code, and the MED is identical. It's 20 for all of those. So we prefer eBGP over IBGP paths, and that's what exactly happened. But we can influence that. But before that test is done, MED is tested first. Since now it's equal, obviously we end up preferring eBGP over IBGP, but we can change that. So in this lab, I'm going to actually change that by doing the following thing. I'm going to make sure that R1 is a preferred gateway for Autonomous System 100 Internet 1 and 2 routers for 10.1.2 prefix, and R2 is preferred for 10.1.4 prefix, which is not currently the case. So how can I do that? If this is my obviously goal, I can advertise on R1 prefix 10.1.4 with a higher MED, or it's called metric in the BGP table, than R2, which is currently advertising as 20. And I'll do the opposite. On R2, when I advertise prefix 10.1.20, I'll advertise it with a higher metric than R1 currently is advertising, which is 20. Let's go ahead and do that. So on R1, I'm going to start off with IP prefix list VLAN 4, the other VLAN, which is going to be, I'm going to be less preferred gateway to that VLAN. So permit, obviously, 10.1.40/24. On the R2, I'll do the opposite. So IP prefix list VLAN 2 permit 10.1.2.0/24. Now I'm going to use a route map, and route map is going to be called route map MED permit 10. I'm going to match on IP address prefix list VLAN, and just make sure I type the right option for this VLAN, which is going to be less preferred gateway. I'll need to set the higher metric than 20 currently. Set metric, let's say 400. For the remaining things I'm advertising, I'll permit them without any modification. That's why I have a permit. The last line is like 999. I am not doing anything for any other prefix. And I'll do the opposite on the other one. On this one, I'm going to match on IP address prefix list. Let's go copy maybe. Set metric 400. So then R1 is going to be 20, advertising this as 20. It's going to be preferred. And for the remaining things I'm advertising, I do nothing. Now I need to obviously now advertise that. So on this one, I'm going to go router BGP 500 for neighbor 10.1.10.254, use route map, and it's called med out. Now router BGP here 500 for neighbor internet 2, use route map med out. And now I need to advertise that. So clear IP BGP 10.1.20.254. I'm going to say out. And here for this neighbor, clear IP BGP neighbor 10.1.10.254 out. So once I re-advertise my prefixes now through that route map, which modifies med, when I jump over here, let's just do okay, and let's have a look. So for the network 10.1.2, R1 should be the best hop, and it is with a metric of 20. For the 10.1.4, internet 1 is gonna be my preferred gateway. So I'm gonna be sending for that 10.1.4 from here. I'm gonna be sending packets to this one. So let's just jump on this one and see that happen. So I'm gonna do the same thing. For 10.1.2, R1 should be preferred gateway, and it is. So I'm going to be sending this to my Internet 1 router here, over here, to go to that gateway, which we saw. And for the 10.1.4.0, my router 2 is the gateway. And that's how we can influence the packets in our algorithm. So that was the step number 6. And if that's equal, we saw that already, the preferred path is eBGP over iBGP. The rest is kind of random thing. We don't have much, many ways to influence the return traffic.